Hi students, today we have to discuss about some general properties of p block elements. General properties. The first case, electronic configuration. Electronic configuration. General properties, electronic configuration. Now, how to write the electronic configuration and what is the general outer electronic configuration? Then how to indicates the electronic configuration. So the valence shell electronic configuration of these elements, which one? 15th group elements. The valence shell electron pair, a valence shell electronic configuration. Valence shell electronic configuration of these elements, valence shell electronic configuration of this group, it can be indicated by ns2 np3. Okay na? ns2 np3. ns2 np3, that is indicated by valence electronic configuration of 15th group elements. Okay, it is also known as outermost shell electronic configuration. It is the outer electronic configuration of these elements. Okay, but the s orbital in these elements is completely filled. We know that concept. And the p orbital are half filled, completely half filled, make their electronic configuration extra stable as compared to other group elements. These elements possess extra stability. Sir, why these elements possess extra stability? In ns orbital is completely filled and np orbital is a completely half filled. Okay na? That's why they can possess extra stable. Okay na? It is a then after how to write the electronic configuration of these elements? Any one of the element like nitrogen, what is the atomic number of nitrogen and what is the atomic number of phosphorus? Okay, but different elements are there: nitrogen, phosphorus, arsenic, antimony and bismuth. These are the certain elements can present in the 15th group. Then how to write the electronic configuration of these elements? Okay, now electronic configuration can be written in the form of like that ns2 np3 in the outermost shell electronic configuration. So the atomic number of nitrogen is 7. We know that concept. The nitrogen atomic number is 7. In the phosphorus is 15. In the nitrogen is 33. In the antimony is 51. And bismuth is 83. Okay, it is the electronic configuration of these elements present in the which group? 15th group. Okay, 15th group. Then how to write the electronic configuration of these elements? Okay, the electronic configuration, as I will give a small hint to these elements. In the nitrogen it can be indicates 1s2 and 2s2 and 2p3. Okay, now in the outer shell, which one is outer shell? 2s and 2p. It is the outer shell, it contains ns2 np3 one more method, one more way to mention the electronic configuration. It helium, noble gas, helium, 2s2 2p3 helium, noble gas, outer shell electronic configuration ns2 np3. Even it is also method used to indicate the electronic configuration of these elements. Okay na? In the phosphorus, after helium, neon 10, then 3s2 and 3p3. Then after one more is indicated by astatine, it can be indicated by argon 18, 3d10, 4s2, 4p3. Okay na? Then one more is indicated by krypton 4d10, 5s2, 5p3, and bismuth, xenon 4f14, 5d10, 6s2, 6p3. This is the electronic configuration of 15th group elements. Okay na? How to indicate, how to write the electronic configuration of these elements? Electronic configuration of these elements can be represented is in the form of like that. Okay na? Then next property, a covalent and ionic radii. Okay, next property, covalent. Next property, covalent and ionic radii. Okay. Sorry, how to define that covalent and ionic radii? Already we know the concept of the ionic radii and one more is the covalent radii. But now in this case, they increase the size. What is the effect of the covalent and the ionic radii? As we go down the group, must and should the covalent and the ionic radii can be increases. As increase in the size down the group, there is a considerably increase the covalent radii from nitrogen to phosphorus. Nitrogen to phosphorus covalent radii can be increases. Covalent radii increases. Covalent radii increases. But from arsenic to bismuth, okay, what is the effect of that covalent radii? Only small increase in covalent radii is observed. Only small increase in covalent radii can be observed. Sir, why the small increase in the covalent radii can be observed from arsenic to bismuth? Due to presence of completely filled D and F orbital have their heavier members. Arsenic, bismuth, antimony, these are the completely filled in D or F orbital. D or which orbital? F orbital. That's why only small increase the covalent radii can be observed from where to where, as astatine to bismuth. What is the reason? The reason is a completely filled D or F orbital in heavier members. In heavier members, the D orbital and F orbital is completely filled. That's why the covalent and ionic radii, as we go down, arsenic to bismuth slightly can be decreases. As we go down the group, must and should covalent radii can be increases, but a large difference can be seen only nitrogen to phosphorus. As we go down, as arsenic to bismuth, yes, a small increase the covalent radii can be observed due to completely filled which orbital? D orbital. Suppose, what is the covalent radius of nitrogen? How to indicate the covalent radius of nitrogen and covalent radius of phosphorus, arsenic, antimony and bismuth? In the case of nitrogen, the covalent radii of nitrogen can be indicated by 70 in terms of picometer. In terms of which one? Picometer. Now phosphorus can be indicated by 110 picometer. In the case of arsenic, it is indicated by 121 picometer. In the case of antimony, that is indicated by 141 picometer. In the case of bismuth, that can be indicated by 148. These are the covalent radii as 70, 110, 121, 141, 148. As we go down the group, what is the effect of the covalent radii? Covalent radii can be increases. Adana ಹೇಳಿದೆ ನಾನು nitrogen to phosphorus increase largely 70 to 110. Next 121, 141, 148. Slightly increase in the covalent radii due to presence of completely filled d which orbital, f orbital. That's why it can be decrease in the covalent and one more, which one? Ionic radii. Covalent and one more is a ionic radii. Okay na? Then after one more they arises here, ionization enthalpy. Sir, then how to indicate that word ionization enthalpy? What is the effect of ionic radii? Is keep it on mind. Ionic radii, as we go down the group, ionic radii can be increases. Okay, as we go down the group, ionic radii can be increases, as well as covalent radii can also increases. Okay na? Next, another property is electronic configuration and covalent and ionic radii. What is the effect of that covalent and ionic radii? As we go down the group, if covalent and ionic radii both are increases. Okay na? Next concept can arises about the ionization enthalpy. So what is the effect of the ionization enthalpy? Ionization enthalpy. So then how to define that word ionization enthalpy? What is the effect of the ionization enthalpy as we go down the group? Actually, ionization enthalpy of the any one of the elements is mainly depends upon the size. Which one? Size. So what is the meaning of that word ionization enthalpy? So the minimum amount of energy is required to remove one or more electrons from a isolated gaseous atom. Keep it in mind. What is the definition of ionization enthalpy? The word ionization enthalpy is defined as the minimum amount of energy is required to remove one or more electrons from the isolated gaseous atom. Which atom? Gaseous atom. That is indicated by ionization enthalpy. Actually, down the group, according to periodical trends, down the group can be ionization enthalpy can be decreases, but along the period can be increases. Every successive member of an element present in the periodic table. As we go down the group, the size of an atom can be increases. When the size of an atom can be increases, with the decrease in the nuclear charge, it can easily to remove the electrons present in the outermost shell. Okay, now ionization enthalpy, once again, a minimum amount of energy is required, or minimum amount of energy is needed to remove one or more electrons from isolated gaseous atom. That can be indicated by ionization enthalpy. So the ionization enthalpy can be decreases down the group. As in the 15th group elements, nitrogen and phosphorus, arsenic, antimony and bismuth. What is the effect of the ionization enthalpy as we go down the group? As the ionization enthalpy down the group can be decreases. Ionization enthalpy down the group can be decreases due to increase in the size of an atom. Okay na? Yes, ionization enthalpy of the 15th group elements is much greater than that of the group 14th elements corresponding periods because of their extra stable half-filled p orbitals and smaller size. The order of successive ionization enthalpy as expected is first ionization enthalpy is lower than that of the second ionization enthalpy is lower than that of the third, but third ionization enthalpy is greater than that of the second ionization enthalpy is greater than that of the first ionization enthalpy. Actually, we know that concept in the electronic configuration of these elements. Keep it in mind. It's very important concept, this one. electronic configuration of these elements means we will consider the nitrogen and the phosphorus, arsenic, antimony and one more is the bismuth. What is the effect of the ionization enthalpy of these elements? Ionization enthalpy of these elements. Ionization of these elements as we go down the group, what is the effect of that word ionization enthalpy? Ionization enthalpy of these elements can be decreases down the group due to increase in the size of an atom. Due to increase in the which atom? Size of an atom. Actually, sorry, the ionization enthalpy, which one and which one and which one and which one possess higher ionization enthalpy and lower ionization enthalpy depending upon the size of an atom. Depending upon the which atom? Size of an atom. Suppose nitrogen and one more is indicated by phosphorus and arsenic and one more is antimony and bismuth. Which element and which element and which element can possess higher than ionization enthalpy? Actually, 15th group elements possess greater the ionization enthalpy than that of the 14th group elements. Sir, what is the reason? The reason is these elements having completely filled s orbital and completely off filled in the p orbital. Completely off filled in the which orbital? P orbital. That's why they possess some extra stability. Extra stable. That's why they can possess higher the ionization enthalpy than that of the 14th group elements. Than that of the which group elements? 14th group element. The successive ionization enthalpy as expected. So the first ionization enthalpy that can be indicated by delta H1 is lower than that of the delta H2 than that of the delta H3. Okay, this one possesses higher, this one possesses lower, this one possesses higher, this one possesses lower because of due to third ionization enthalpy means these electrons tightly held with the nucleus. During that situation, more energy is needed to remove the outer shell electron containing the electron. That's why they can possess higher the ionization enthalpy than that of the second and than that of the which one? First one. Okay, suppose we will consider the first ionization enthalpy of any one of the successive elements. First ionization enthalpy. Okay, first ionization of enthalpy of these elements. So how to indicate the first ionization enthalpy of this element? In the first ionization enthalpy of the nitrogen. Observe ಮಾಡಿ. Siri, if first ionization enthalpy of the nitrogen is indicated by 1402 and the second first ionization enthalpy of the phosphorus is indicated by 1002 and 947, 834 and 703. These are the ionization enthalpy. First ionization enthalpy of nitrogen and phosphorus and arsenic and antimony and one more is a bismuth. Okay, as we go down, first ionization enthalpy can be decreases. We know that concept. In the second ionization enthalpy of nitrogen and third ionization enthalpy and fourth ionization enthalpy. But in the second ionization enthalpy can be indicated by 2856. In the another element 1903 and 1798 and 1595 and 1610. As we go down, actually exceptional case can arise in the antimony and one more is a bismuth due to inert fair effect. Okay na? Yes, 2000, 1900, 1700, 1600. As we go down, as again enthalpy can be decreases. Okay. Yes, we will consider different examples are there and different ionization enthalpy. Our ionization enthalpy down the group can be decreases. Okay. First ionization enthalpy, second ionization enthalpy and third ionization enthalpy. Even it is also very important property of an 15th group elements. Okay, and next one more property can arises about the 15th group elements. About the properties of the 15th group elements that can be indicated by electronegativity. Already we know the definition of electronegativity. Sorry, on the basis of which factor electronegativity can be arises. Sorry, electronegativity is defined as ability of an atom in a molecule. We know that concept, that one. Electronegativity. The ability of an atom in a molecule, the shared pair of electron completely draws towards it. Ability of an atom in a molecule, not atom. ability of an atom in a molecule, the shared pair of electron completely runs towards it, which one can completely runs towards it, that one is a more electronegative than that of the another atom. Suppose we will consider the X and X prime. These are the two atoms are there, but it is a molecule. Okay, na? It is a hydroatomic molecule, but it contains the one pair of electron present between the X and X prime. The shared pair of electron completely runs towards any one of the atoms. Suppose X prime can completely runs towards it. Now it can carries the negative, it carries the positive. Which one can completely runs towards it? That is a more electronegative. And which one can lose the electrons, that can act as a less electronegative than that of that. Okay. Actually, electronegativity of 15th group elements as we go down the group can be decreases. We know that concept in the periodic table. The first most electronegative atom in the periodic table is a fluorine. Second most is a oxygen. Third most is a chlorine. And the fourth most is a nitrogen, that is indicated by 3.0. The element nitrogen. The electronegativity of nitrogen is a 3.0. The electronegativity of an phosphorus is indicated by 2.1 and 2.0, 1.9 and 1. Nearly equal to same 1.9. This one is the electronegativity 3.0, 2.1, 2.0, 1.9, 1.9. It is exceptional case. But as we go down the group, what is the effect of the electronegativity? As we go down the group, electronegativity gradually decreases due to increase in the electropositivity character. Okay, now these are the some of the general properties of which group elements? 15th group elements. Once again, in the first general properties, electronic configuration, then after atomic and covalent and ionic radii, and the third one is indicated by ionization enthalpy, and the next one is indicated by electronegativity. These are the some of the properties, general properties of the any one of an element present in the periodic table. Sir, one question can arise here. Which one of the following has lowest melting point? As nitrogen, phosphorus, arsenic, antimony. Already I gave the concept about the melting point, boiling point. Just observe that melting and boiling. Which one can process higher melting and higher boiling? Okay, different concept can arise us about the 15th group elements. Okay, na? Yes, and the next after the completion of these properties, next go to the some of the physical properties. Any doubts on this class? One is indicated by atomic and ionic radii or covalent radii, and one more is indicated by electronic configuration, then ionization enthalpy, and one is electronegativity. Okay, na? Then after that we know the physical properties. Sorry, what are the physical properties can arise on the 15th group elements? Already we know the concept in the previous unit. Which one is a metal, which one is a non-metal, which one is a metalloid, and which one is a gas, but different properties can possess about the physical properties. Okay, now is all the 15th group elements are generally polyatomic. All these 15th group elements are polyatomic. We know that concept, polyatomic. Suppose we will consider the nitrogen. Nitrogen cannot exist in the elemental state, but it can exist. It does not exist in single state, but it can exist in combined state. I mean, it can exist in the form of not monoatomic. It is a diatomic. It is not a monoatomic, it is a diatomic. In the phosphorus can also exist in the not diatomic, it is a polyatomic. In the antimony, bismuth, and one more is indicated by arsenic. All these elements can exist in the polyatomic. Okay, now then after dinitrogen is a diatomic gas. Already we know that concept. Dinitrogen, that is indicated by hint 2. It is a diatomic gas. It is a colorless gas. Diatomic gas. While others are solids. Remaining elements or remaining elements can exist in the form of solids. Form of which one? Solids. Nitrogen and phosphorus, we know that concept. Nitrogen and phosphorus both are non-metal, and arsenic and antimony both are metalloid, and bismuth is a which one? Metal. Bismuth is a metal. Okay. Then after, this is due to decrease in the ionization and increase in the atomic size. Already we know that concept. With increase in the metallic size, must and should the ionization enthalpy can be decreases with increase in the atomic size. As boiling point increases from top to bottom, as we go down the group means with increase in the size of an atom, must and should the boiling point and one more is a melting point. If boiling point and melting point both can be increases down the group. Boiling point increases from the top to bottom in the group of the, but the melting point increases up to arsenic and then decreases up to bismuth. Depending upon the nature of an element. Except nitrogen, all the elements shows is very important concept. Except nitrogen, all the elements they can show allotropy. Okay, so the allotropes means different forms of the same element, but they can form different. Okay, that's why nitrogen cannot exist, but the remaining rest of the elements like phosphorus, arsenic, bismuth, antimony, they show allotropes, but nitrogen cannot show. But nitrogen is a diatomic gas. Remaining rest of the elements all are the polyatomic. Okay, but nitrogen is gas. Remaining rest of the elements are solids. Okay, but as we go down the group, with increase in the size of an atom, that's why covalent radius can be increases with a decrease in the ionization enthalpy. These are the some of the properties like physical and some of the general properties. In the next class, we will study about oxidation state and trends in chemical reactivity. Trends in which one? Chemical reactivity. We'll discuss about in the next class. Okay, thank you.